Today we're going to talk about section 4.4 of your BJU Press Algebra 2 textbook. This lesson is all about solving quadratic equations. So we learned four different ways to solve quadratic equations. And first I'm going to talk about how do you know which way is the best way to solve an equation. So remember, you can solve an equation using any of these methods, but this lesson is mainly about determining which way is the best way or the fastest and easiest way to solve a quadratic equation. So the first way and the easiest way is the square root method. We want to use the square root method when we just take the square root of both sides when our b value is 0. And you're like, wait, what was the b value again? Well, remember, if we have our general form, ax squared plus bx plus c equals 0, our b value is the number, the coefficient in front of the x term. So if b is 0, that means that there is no x term at all. So you would have something like ax squared plus c equals 0. So if you have it in that form, you want to use the square root method where you solve for x by moving everything to one side and then taking the square root of both sides. The second way to solve a quadratic equation is the factor method. And you want to use the factor method when you have a trinomial that factors easily. So you can easily do the box method or reverse the FOIL method, and you can determine your factors easily. You also can use it if there's no constant term or that c term, right? If there's no constant term and you just have ax squared plus bx, then you can factor the x out and then solve for x. So the next way to solve for a quadratic equation is the quadratic formula. And you want to use the quadratic formula in all other cases. So if it doesn't easily go into the square root method or easily factor, then just go ahead and use the quadratic formula. It will always give you an answer. So remember, the quadratic formula is the x is equal to negative b plus or minus square root b squared minus 4ac over 2a. So the b and the a and the c, these all come from that general form that we use. All right, so now that we went over those three methods, you're like, wait, what about that fourth way, the completing the square? Well, the completing the square is actually not really practical for solving quadratic equation because it's such a long process. You're only going to complete the square when you're directed. And you're like, well, wait, why did we learn completing the square in the first place? Well, completing the square has two values. The first value is that in order to get the quadratic formula, the reason the quadratic formula works is because of completing the square. So if you understand completing the square process, then you understand why the quadratic formula works. The second value is because when we learn about parabolas and conic sections, we're going to need to know how to complete the square. So tuck that away in your brain somewhere because it's going to come back in future chapters. So let's do some examples on using these different methods and identifying which method is the easiest way. So we'll start with example 1, which says solve 3x squared equals 54. So I noticed that there is no b value here, so I'm going to use the square root method. So I want to solve for x by getting everything to one side. So I'll divide both sides by 3 first. So I get x squared is equal to 54 divided by 3 is 18. My last step is to square root both sides. So x is equal to the square root of 18. Remember, I do not want a decimal here. However, you can simplify this. Oh, one more thing. Remember, when you take the square root of both sides, you get plus and minus. You get two answers because we're dealing with a quadratic. Okay, so plus or minus the square root of 18. If I want to simplify that, I have to think of it as this. What are the factors of 18, and are any of those factors perfect squares? Well, 18 can be rewritten as 2 times 9, because 2 times 9 is the same as 18. And once I've done that, well, I can split that up. I can say, well, that's the same as saying the square root of 9 times the square root of 2. Okay, so now that I have the square root of 9 times the square root of 2, the square root of 9 is 3. So now I have plus or minus 3 square roots of 2. And that's how I simplified the square root of 18. Okay, so let's move on to our next example, example 2. And example 2 is going to be 4x squared minus 12x equals 0. So I notice that there's no constant term, no c value here, so I'm going to go ahead and use the factoring method. I'm going to factor out an x, but I'm also going to factor out a 4, because 4 is also a greatest common factor between 4 and 12. So I'm going to factor out a 4x, leaving me x minus 3 equals 0. So now that I've got two factors, I have 4x times x minus 3. I can set those both equal to 0. So 4x equals 0 or x minus 3 equals 0. So that means either x equals 0 or x equals 3. All right, example 3. So I want to solve 3x squared minus 4x minus 1 equals 0. So this one, I have a b value, okay, and I also have a constant. So I think, can I factor this easily? If I were to use my box method, would I be able to figure this out? I could try a couple of things and see if something comes easily to me. However, I really don't like having to do the box method when I have a number in front of x squared. So I'm going to go ahead and just use the quadratic formula to help me out. So quadratic formula, remember, is x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. So I'm going to plug in my values. So remember, this is a, this is b, and it's negative 4, that's b, and then c would be negative 1. So negative b, so negative 4 plus or minus the square root, negative 4 square, notice my use of parentheses, minus 4 times 3 times negative 1. All over 2 times negative 1. Okay, so from here, we just simplify. So if we have negative 4, that becomes 4 plus or minus. Negative 4 squared is 16. 4 times 3 times negative 1 is negative 12. So we have minus negative 12. So we have plus 12 all over negative 2. So simplifying that, 16 plus 12 becomes 28. So when we have 28, we can simplify that. So remember, when you're trying to simplify a radical, you think, what two numbers can I multiply together to get 28, one of them being a perfect square? So there's many factors of 28. There's 1 and 28, 2 and 14, actually, I think that's it for the factors of 28. So, but we can use there's one more, 4 and 7, I'm sorry. So 2 and 14 and 4 and 7. So if I use 4 and 7, I know that 4 is a perfect square, and that's what I want. So I'm going to rewrite 28 as 4 times 7. And if I do 4 times 7, then that means I can rewrite it again as the square root of 4 times the square root of 7. And the square root of 4 is 2, so now I have 4 plus or minus 2 times the square root of 7 over negative 2. And then I can simplify. Okay, so when I simplify, what happens is that this negative 2 is going to go underneath each term in the top. So I have 4 over negative 2 plus or minus 2 square roots of 7 over negative 2. Okay, Okay, really quickly, I just realized that we're using the wrong we used the wrong a value. So the a value should have been 3. So this should have been 3 here. So 2 times 3 is actually 6. So your denominator in all of these simplified steps should be 6. So quick change. There we go. All right. So when we simplify now, we have 4 over 6, which is the same as saying 2 over 3. When we simplify, plus or minus, and then 2 over 6 square roots of 7, that simplifies to, 2 over 6 simplifies to 1/3. So the square root is 7 over 3. And now we can rewrite one more time. We're going to just write this as one fraction. 2 plus or minus the square root of 7 over 3. And that is as simplified as it gets. All right, let's do another example. Example 4. Where we have 4x squared plus 49 equals 28x. So the first thing I want to do is I want to put this in general form. So I'm going to move that 28x to the other side. So I'm going to subtract 28x from both sides. So I get 4x squared minus 28x plus 49. And now it looks like in general form. So this one looks like it will factor easily. So I'm going to go ahead and use my box method to figure out my factors. So I want 4x squared here. I want 49 here. But I want it to equal negative 28x here. So when I think about my factors, let's try 2 and 2. So 2x and 2x to make 4x squared. And then 7 and 7 make 49. I know I want to add up to negative 28, so let's make that negative 7 and negative 7. So, because that will still equal positive 49 when we multiply, but then we have negative 14x, which adds up to negative 28x. So I get the factors 2x minus 7 times 2x minus 7 equals 0. And it looks like those are the same thing. That's awesome. Okay, so that means I just have to solve it once. 2x minus 7 equals 0. So 2x is equal to 7, which means x is equal to 7 over 2. All right, so now that we've gone through the different ways to solve a quadratic equation, let's talk about something else. Let's talk about a word called the discriminant. So the discriminant is a new vocab word for you. And the discriminant is what we're going to use to look at the characteristics of our solutions, or the nature of our solutions. So remember, the solutions are when we solve for x. So you notice sometimes when we solve for x, we get a negative number, sometimes we get a rational number, sometimes we get a number with a radical. We call that an irrational number. So we get all different types of numbers. Well, we can tell what type of number we're going to get before we solve it just by looking at the discriminant. The discriminant is going to be from the quadratic formula. It's the radicand of the quadratic formula. So the radicand is what's underneath the radical sign. So if the quadratic formula is x is equal to negative b plus or minus square root b squared minus 4ac all over 2a, and the discriminant is the radicand, it's what's going to be inside the radical symbol. So it's all of this right here. So our discriminant is going to be the b squared minus 4ac. So if it says find the discriminant, it's saying do this. Do b squared minus 4ac. And that will tell you your discriminant. And then once you know your discriminant, you can characterize what type of solutions you're going to get. So let's take a look at the nature of solutions of a quadratic equation. So I'm going to do a little chart. So again, we're looking at the nature of solutions. So we're going to have three cases. Either your discriminant is going to be greater than 0, your discriminant is going to equal 0, or your discriminant is going to be less than 0 or negative. Okay, so based on your value of your discriminant, you can tell me the number of solutions you're going to have. You can also tell me the general nature. So is it going to be a real number or a complex number, which means an imaginary number? And then you're going to be able to tell me the specific nature. So is it going to be a natural number? Is it going to be rational, irrational, etc.? So specific nature. Okay, so when your discriminant is positive, you're going to have two solutions. They're going to be real, which means they won't be imaginary. And this is what it's going to be. It's going to be rational if D is a perfect square. And then it's going to be irrational. Sorry, rational is a Q, not an R. So rational if D is a perfect square. It's going to be irrational, which is Q prime, if D is not a perfect square. So remember, rational means that it's either a fraction or a whole number or a negative number. Irrational means that it's going to be like something that has a square root, okay, the square root of something. So now what about if D is equal to 0? You do the b squared minus 4ac and you end up with 0. In that case, you're going to have one solution. It's going to be real. And it's going to be rational. So simple, easy, it's just going to be rational. Now if D is less than 0, then that means you're going to have two solutions again. These are going to be complex because if your D is less than 0, that means it's negative, which means that you're taking the square root of a negative number. You can't take the square root of a negative number, which means it's an imaginary number, which means it's complex, okay? And so your specific nature is going to be the conjugates. And you're like, what are conjugates? Well, the word conjugate, it's the term that refers to the sum and difference of two quantities. So it's the plus and the minus. Remember how we kept doing plus and minus something? That's what it's talking about. So for example, if you have 3 plus the square root of -1, the conjugate would be 3 minus the square root of -1. It's just changing the plus to a minus or a minus to a plus, depending on what you have. So that's what conjugates are. All right, so let's do a quick example of classifying a solution. So we're not actually going to try to find the solution. We just want to classify it. We just want to know the number of solutions, the general nature, and the specific nature. So example 5, we want to classify 3x squared plus 5x plus 8 equals 0. So we're going to do the discriminant. Remember, the discriminant is the b squared minus 4ac, the part that's in